PSPM set 2, question 2. So we start with question A, which states that emission line spectrum is formed when an electron falls from a higher energy level to a lower energy level. Okay, question I. Calculate the wavelength and frequency of light that forms third line of bracket series. Okay, so if you remember the series state that the first series is Lyman series. Okay, I will write here Lyman, and then the second is Balmer, the third is Paschen, fourth is bracket, okay, and the last one is Fun. Okay, so it states that it's from bracket series. So we know the final n is at 4 because bracket series is nf is equals to 4 for bracket. Okay, so the question wants us to calculate the wavelength, which is lambda, and also the frequency, which is nu. It's not f, okay, it's v. So to calculate wavelength, we have to use this formula, where the n1 should be less than n2. So make sure you write the formula because formula will get marked. Okay. And then one mistake that students always do is the RH value. Okay, the Rydberg constant. Which do you need to use? Got two RH. One is 1.097 times 10 power to the 7 and m-1, and another one is 2.18 times 10 to the power negative 18 joule. Okay, so how to know which we need to use to calculate the wavelength? We know wavelength must be in unit m. So between these two, this ends with m, this one ends with joule. So it's obvious that we need to use this. This one, joule, when do we need to use this? Is when we calculate the energy, because energy symbol is joule. Okay, so and then this one, here they say third line. So the first line will be n equals to 5 to n equals to 4. The second line will be n equals to 6 to n equals to 4. So the third line will be n equals to 7 to n equals to 4. So we have the n final, we have the n initial. We can calculate the wavelength. So this is how we calculate the wavelength. Just substitute into the formula and you will get 1 over lambda. Don't forget to change this to lambda because the question asked lambda. The question did not ask 1 over lambda. So here we will get mark. Okay. Then if you do until here, then you won't get mark. Okay. You're supposed to calculate the frequency as well. Okay. So to calculate the frequency, we have this formula, which is nu equals to c over lambda. C is constant, which is speed of light. So we can substitute it here, and this one also we already find here. So we can just substitute it here, and we will get the frequency value, which is this. And here you will get another mark. Okay. Okay, for the next question, the questions want us to sketch the spectral lines for bracket series. Okay, and then state the electron transition for the third line produced. Okay, as we know just now, third line is n equals to 7 to n equals to 4. And then the question wants spectral line, not energy level diagram. Okay, so we will draw this. And then it asks us to state, so we state n7 to n equals to 4 will form the third line. And then for safety purpose, we are supposed to write this. Okay, so we will get marked. That's all. For the next question, the question gives us that element W has 21 proton number. Okay, and the question wants us to write the electronic configuration of W. So first of all, to write the electronic configuration, we have to know the proton number, which is given. So when you write, make sure to write it V21 smaller, not V like this. This is totally wrong. This is correct. Okay, and then just write. For this, you have to remember this. Okay, so how to write? First we start with 1s2, then 2s2, and then 2p6 cs2. Remember that S can only fill 2 electrons. Okay, so S 2 electrons, P 6 electron, and then D 10 electron. Okay, so according to this, we will write the electronic configuration, which is 21 proton numbers. So 1s2, 2s2, and then 2p, you can see here and here, 2p6, and then 3s2, and then 3p6. Okay, 3p6, and then 4s2, and then 3d1. Why is it 3d1? Why is it not 3d5 or 3d10? Because the proton number. The proton number is only 21. So this one is enough. This is 21 total. If you count this, you will get 21. Okay. So for the next one is draw the orbital diagram and give the sets of quantum numbers for the valence electron. Okay, so for the valence electron, here means this part. This part is the valence electron. So the orbital diagram, you have three choices, which is box, platform, or concentric circle. The easiest will be box, and it's clear, which means like it's easier to understand. Okay, so we have 4s2 and also 3d1. So 4s we write here, and then in the box we have to draw 2 arrows because 4s2. Okay, and then for D we have to draw 5 box because D total has 10, it can fill until 10 electrons. One this box will have 2 electrons, so we'll have 5 box. And then for 3D we only have 1 electron, so you have to draw 1 arrow. Make sure to draw the arrow like this and like this. If let's say it's 3D8, so make sure to draw the box like this. 1, 2, 3, 4, 5. It's 1, 2, 3, 4, 5, 6, 7, 8. It's supposed to be like this. This is the correct way. You are not allowed to draw like this. Not like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is long. So you're supposed to draw like this. And then the question wants us to give the sets of quantum numbers for the valence electron. Okay. So set of quantum numbers is N, L, M, S. What does this mean? N is the principal quantum number. L is the angular momentum quantum number. M is magnetic quantum number, and S is electron spin quantum direction. Okay. So for this, N is the principal quantum number, which is 4. Okay. One more thing, you are supposed to write this for the examiner to know the order. Okay. If without this is totally wrong. But with this is correct. Okay. So N is 4. L can be any number from 0 until 3. For M, it depends on the value of L. Let's say if L is 1, then M will have 3 possible values, which is -1, 0 and 1. You can write any of these. The spinning quantum number will only have 2 possibilities, which is +1/2 or -1/2. Here I choose to write +1/2, okay, which is correct. For the next one, your label and then the numbers, which is the principal quantum number is 3, and then the L can be any number from 0 to 2, so I choose 2. And then for 2 we have 5 possibilities, which is -2, -1, 0, 1 and 2. I choose -2. Okay. And then for S, same goes to this. We have +1/2 and -1/2. I choose to write +1/2. Okay, so for the next question, the question wants us to draw the shapes of orbital that accommodate valence electron for element W. Okay, so we know the valence electron for element W is 4s2 3d1. So the shapes of orbital for 4s for S is sphere, and then for 3d we have to draw clover shape of orbital. Okay, so for 4s, the shape is still the same, which is sphere, but then the size must be a bit bigger because the principal quantum number is 4. So it's supposed to be a bit bigger. If you draw like this, it's correct. For here, we are not supposed to write 4s1 or 4s2. This is wrong. You're only supposed to write 4s. Okay, and then for 3D shape of orbital, you have to draw clover leaf shape. Okay, so for 3D we actually have 5 shape of orbital, or 5 clover shape drawing. Okay, for 3D1, just now the valence electron is 3D1. So the principal quantum number is 3. So the shape should be a bit bigger, which is like this, because the quantum number is 3. So here I draw 3 orbital. So the first one is 3D Z square. This one, not the electron number. This is the shape. Okay, the shape is dz square. But then because the principal quantum number is 3, we write 3 here. And then this one also we are supposed to write. Okay, it is necessary to write this. Same goes for 4s just now. We are supposed to write this. So here I draw 3 shapes. The first one is 3dz square. The second one is 3dxy. Okay, xy. And then the third one is 3dx square minus y square. In your lecture note, we have 5 drawings. So you can choose which do you think you can draw, which is the easiest for you to do. So that's all from me.